Yesterday we talked about reflection, reflection. And you can find the image of mirror, concave mirror, and convex. But we'll show you the different image from concave and convex mirror. Okay? Remember, when we have to find the image of a concave, but we have to draw the principal axis. Draw principal axis first, and then put mirror. This is concave mirror. Okay. So put see and get a focus. The distance from focus to mirror have equal to the distance from C to F. Okay? Have equal. And then put the object. After that, draw the first rule, ray of light from the bottom of the object to attack the mirror and reflect that focus. Okay, focus. Then draw another ray from the bottom of object has focus, stick at mirror, and then reflect. Reflect this is parallel. Okay? When the intersection of this ray and this ray intersection is here, the image brought to here. Okay? Yeah. Image. Okay? It is real image. Okay? So, okay, I will show you compare about the image of concave mirror and convex mirror. Will be first between convex. Intersection of ray. So, image is here. Okay. This is image is here. When the convex mirror, draw the axis. Principal axis. Convex mirror. The convex mirror focus and center of conversion behind the mirror. Okay. This is focus. And when I do the same, this is the distance between the focus and mirror. Focus 2 and this con attached here. But when the ray of light attacks the convex mirror, the ray have to reflect, but the concave mirror is converging the ray to the focus. But the ray of light when speak at mirror have to spread out. Okay? But we have to draw as here. Okay. Okay. You see on your book. You see on your book on the page 174. Will show you. Okay. Continue. We will draw the similarity rate of light as the focus. This is a similarity rate, not a real ray of light. It is real ray of light. It is similarity rate of light. Okay, and then we will draw the ray of light passing center or passing. Okay, passing the center. The intersection of here. So image on here. Okay? Yes. This image is virtual image, not real image. This image is real image. Okay? Because this image born from the real ray of light. The real ray of light crossing is here, but this mirror, this light not real of light. It's a similarity of ray of light crossing here. The image born here, and this image is virtual. Okay?
That's why in convex, it's diverging. Diba nag-scattering, diverging. Sa concave, converging.
Okay. Thank you. This is a different image from concave and convex. The most of image from concave is real image. And the image from convex is virtual image. Just have a one point for object from for the image is virtual when the object would be between focus and mirror. The image right, not intersect. For far, not intersection, but we can draw the zero line behind the mirror and behind the mirror. This is the intersection of points. So the image on here. Okay? So this is a virtual image. In the context mirror, where the objects, the locus of object between focal and mirror, the image is virtual. So another locus is real image. Okay? Okay. But concept mirror, when we put the object anywhere, the image is virtual image only. Okay? Okay. And yesterday we have a two equation of mirror and reflection. Okay? Remember? The equation 1 over DO
plus
plus 1 over
D1
DI equal
over R.
yeah. This is the equation of diffraction. And the magnification
Negative
and
1 equals negative DI
over
D.
DO. Remember, this is the equation for describe the image, for description image. Okay? Okay. Remember.
Magnification describe
Look at the page 126 on your book. On your book. 126. Sample problem 6.4. An object is placed 20.0 centimeter in front of a concave mirror of radius 50 centimeter. A. What is the focal length of the mirror? And B. Where is the image located? C. Characterize this image. Characterize this image. Form the question. 126 on your book. Okay. From the question we have given R is equal 50 centimeter. Okay? And object is placed. Object is DO is equal 20 centimeter. And A. Ask about A. What is the focal range? Focal range. 5 the same. How far?
how far or where?
The symbol is phi, phi, F,
R,
I, phi, F.
R over.
Yeah. F is
R over 2.
R over 2.
Yeah.
So
50 divided by 2.
50 over 2 is equal
25.
25 centimeters. Okay. And B. Ask about where is the image located? Where is the image located? Ask distance of object. Of object? Of image. So B asks about the eye. Okay? We know DO is equal to 20 centimeter. So you want to find the eye.
Yes.
You can use equation of reflection. Okay? From 1 over, okay, 25 at 1 over the eye.
Yes.
Okay? You want to find it. Is equal 1 over 25. This is 25. This is DO. DO is equal 20. 20. So you have to transpose. Okay. You transpose 1 over. I will transpose it to here. Okay?
Yes.
Okay. I is equal 125 minus 120. 1 over 20.
Yes.
Okay. And so then multiply it by 2 over 2. And multiply this here by 5 over 5. Oh, 2 over 2. No. We have to 100. Okay. 200. So 4 over 4. And multiply by 5 over 5. Okay. So 1 over di is equal 4 over 100. Subtract 1 over 5 over 100.
Yes.
So, yeah. 1 over di is equal 4 minus 5.
Negative 1.
Negative 1 over
100.
and we have is okay. So di is equal 100 over 1. Okay. So di is equal negative 100. Unit is
Centimeter.
centimeter.
Yes.
Okay.
Yes. Reciprocal. If it's positive, you place it negative. It's negative.
When di is negative, negative because
Divided.
okay. And then see characterize this image. Characterize this image.
What's the characteristic of the image? Is it small, bigger,
Yeah.
smaller?
Small.
How do you know? Small or same or bigger? You have to. Yeah, you have to choose
Yes.
equation for describe it. Okay. This image. How we know? Use integration. Form magnification is equal d minus d I over d O. Okay. This equal di. Di is okay negative 100 and 20. Okay. Is equal 0. So 10 over 2 and negative is okay. So 2 is 5. Okay. So the image is bigger than object. Okay, bigger than the object. Okay. You understand it? Okay. Di is equal negative 100. So when we draw it, see, and object, the plus, and then this image is here, far from the mirror ball. Okay, so this picture is okay. Which is exercise 6.4.
Here now. So you didn't want to stop. No. Any questions so far?
Any questions?
Any questions?
Any questions?
Okay. And so you will be to the next.
Okay, practice exercise 6.4.
Who wants to read?
Who wants to read?
Clark, Erving.
And you clap.
Practice exercise 6.4. An object is placed 36.0 centimeter in front of a concave mirror of focal length 32.5 centimeters. What is the radius of curvature of the mirror? Where is the image of the object located? Characterize this image.
Okay, get your paper. Solve.
Okay.
Teacher Tmaw will analyze the problem. So you can
Follow me.
follow. Get your paper. Try to solve it. Teacher Tmaw will analyze it.
Okay, follow me. From the question, an object is placed 36 centimeters in front of a concave mirror of focal length 22.5 centimeters. Okay. From the question given, object located is the 36 is 36 is the eye, yes, the eye is equal to 36 centimeters. And 22.5 centimeters is focus length. Is L equal 22.5 centimeters. Okay? What the question asks A. What is the radius of curvature of the mirror? Curvature of mirror. Radius. Radius. A. R is E. Okay? We know F. R is equal to, okay, to F, 2 times F, okay, 2 times F is equal 45 centimeters, okay, correct. B. B. What is the image of the object located? Located? Why? That's about the eye. Okay. The eye. This is an. We can use this question. Oh, it's the O, not the I. Sorry. Oh, so sorry. Okay. On the eye. Okay? We use this equation. Okay. So 1 over the O plus 1 over the I is equal 1 over F. Okay. And 1 over the O is 36. 36. And 1 over the I. We have to find it. And 1 over it. 5. Okay. 1 over the I is equal
1 over 36. 22.5.
Equaling 1 over
36.
okay.
Times 4 by
That's what by
4 times 4 over 4.
It's fine. Sure?
2.
Okay. Don't worry. You have a calculator. Okay? You can do this. Okay. So, can divide it. Can divide this. And okay. If you want to solve it by yourself, 1 over the I is equal 1 over 22.5. You can multiply this time here. Yes, okay. And minus 1 over okay. You can do this for the division detail. Okay. Okay. But you have a calculator. You can do it for help you. Okay, it's helpful. It's the best helpful for you. Okay. Okay. So 1 over the I is equal
36 over 810.
36 over
810.
810. Okay? Minus 0.5 over
810.
810. And 1 over di is equal 36 minus 72.5 is equal 13.5 over 810. So di is equal 810 over and b. Then we got calculated. How much?
60.
16.
60.
6060.
Oh,
Yeah, 60.
60. Okay. 60. Okay. In unit centimeter. Okay.
Yes, sir.
And it's a positive, not negative. Okay. Because the 36 minus 72.5 is more than this, bigger and small. Not negative. Okay. So this is the answer. And C. Characterize this image. Characterize this image. When we want to characterize, when we want to describe, we can use this equation. Okay? Okay. Okay.
60 po.
Oh, 60. 60 divided by
30, 36.
equal
Negative.
negative in the absolute
1.6.
1.6. Okay?
Negative.
This is the absolute symbol. Mean absolute symbol in
Negative.
in mathematics. When it is positive or negative in the absolute symbol, when we answer, we have to answer positive only. Okay? Okay. The
Absolute value.
magnitude is 1.6. Small, same or bigger?
Always
Bigger.
Bigger.
Bigger than the object. Okay.
0 point.
Okay. Completed.
You know how to
Have a
describe.
question?
A question. Answer. If there are no questions, it's answer.
No question.
Answer.
Wow. All of you is correct.
No.
Oh no.
Why?
Why?
Stop computing. Oh, did you
Why?
solve it? Oh, no. No grade.
Oh no grade. Maybe you said no grade.
No grade. No grade. First, no grade.
Is there will be having
I'll show you.
Okay, you understand about reflection of light.
Even if you take this lesson,
can we say what like, for example, this method, this method, what in Thailand, I have internet. We have many students in the English program. And the student Okay. You understand the reflection of light? Okay. I can continue to the refraction of light. I can continue refraction. Refraction. Okay. The next chapter. The next chapter is chapter 7. Reflection of light. Refraction is reflection. In the next chapter is refraction of light. What is the refraction of light? What is reflection?
Why the teacher is asking? Refraction. The next topic.
Oh, good. Good question. Right.
For me, the refraction when the light is
the light
passing through one object, it makes a path that the light comes from one passing through
Good. Okay. Thank you for the answer. Reflection of light is happen when the ray of light passing the medium and passing to the other medium. Just as the ray of light from the sun travel to the outside room. We have a glass. Before the ray of light enter here, the ray of light has the air. Air is the one medium, and glass is medium two. Okay. The air have a density different gases. So it can be to the speed of light is changed. So this is for the to be born refraction. Okay. So I have video for starting to learn different refraction. refraction of light. Try to look here. I will before you learn.
Refraction of light. You would have probably noticed that a spoon placed in a glass of water looks bent at the surface of water when viewed obliquely. The print on a page appears to be raised when the book is held behind a glass bottle filled with water. All these are the tricks of light. We shall explore how a light ray travels from one optical medium into another. You will need a glass of water, milk, pencil, a torch, aluminium foil, elastic band, needle. First, you need to prepare a point source of light. Observe how the torch is adapted as a point source of light. Here, use the point source of light. To give a cloudy effect for the glass of water, add a little milk to water.
Milk.
Darken the room. Shine the ray of light from the torch to the bottom of the glass. Observe the path of the ray of light. The path is crooked. This shows that a ray of light changes its direction of propagation as it travels from air to water. Similarly, a pencil which is partially dipped in water appears bent or broken to the observer. When a ray of light passes from air to water, its speed changes. Due to this, there is a change in direction of the ray. This change of direction suffered by a ray of light as it passes obliquely from one optical medium to another optical medium with different optical densities is known as refraction. Note that whenever a ray of light is incident on a surface separating two media, a small fraction of the light always gets reflected. Refraction can make an object appear to be in a different position. For the same reason, the part of the pencil which is submerged looks as if it has moved away from the part above water, and it appears fatter. Now, let's understand the phenomenon of refraction by studying the ray diagrams. Whenever a ray of light is traveling from a rarer medium to a denser medium, the refracted ray bends towards the normal. Here, IO is the incident ray, OR is the refracted ray, I is the angle of incidence, and R is the angle of refraction. In this case, angle I greater than angle R. If the ray of light is traveling from a denser medium to a rarer medium, the refracted ray bends away from the normal. Here, IO is the incident ray, OR is the refracted ray, I is the angle of incidence, and R is the angle of refraction. In this case, angle I less than angle R. For definitions, click on the labels. The ray of light striking the surface of separation of the media through which it is traveling is known as the incident ray. The perpendicular drawn to the surface of separation at the point of incidence is the angle which the incident ray makes with the normal at the point of incidence, the angle which the refracted ray makes with the normal at the point of the ray of light that has changed its direction at the surface of the ability to refract light is called the refractive index. Refractive index of a medium is equal to the ratio of the speed of light in vacuum or air to the speed of light in that particular medium. Refractive index is equal to speed of light in vacuum by speed of light in the medium. This ratio is always a constant for a given pair of media. It is represented by a Greek letter mu. Here are some of the effects of refraction. A straight pencil PQ, when immersed obliquely in water, a portion of it appears to be shortened and raised up as P1, Q1 under the water. Let us understand this with the help of a ray diagram. Rays of light from the point Q are traveling from water to air. As the rays of light are traveling from a denser medium to a rarer medium, they bend away from the normal. After refraction at the surface, they appear to be coming from point Q1, which is true for each and every point of the part of the pencil which is immersed in the water. During spear fishing, the fisherman aims at the tail of the fish. When a fish in clear water is viewed from an angle, its image appears ahead of its actual position, as it is raised up due to refraction of light from water to air. Thus, if the fisherman aims at the head of the image of the fish, the spear will hit in front of the actual fish. However, if the aim is at the tail of the image, it is likely to hit on the head of actual fish. Go through the ray diagram to understand this.
Oh.
Twinkle, twinkle, little star. That's what we were taught. But do they really twinkle? No. Stars do not twinkle. Let us now learn about why they appear to do so. The rays of light coming from the stars travel through the layers of air of varying densities. These rays get refracted continuously and they bend towards the normal as the refraction is from a rarer to a denser medium. The movements of air and convection currents causes a change in the density of the layers of air. As a result, the position of the image of the star goes on changing after every short interval. These different positions of the images formed at short intervals of time give the impression that the star is twinkling. At dusk or dawn, the sun appears to be larger than at noon. This is because when the sun is near the horizon, the rays of light coming from the sun have to pass through layers of air of increasing density. Due to continuous bending of light, the sun appears to be larger. At noon, the sun appears to be smaller than at dusk or dawn. This is because the rays of light that fall normally on the surface of the earth do not get refracted.
Okay. Video show the reflection of light. For starting to learn reflection of light.
continue the lesson. We are on refraction.
Yes.
High classes, follow the law of
Picture back.